Hello, once again, good afternoon, good day everyone. I am Rosetta Orquesta and welcome to Pantasmalaya. Okay, so in the previous video, we talk about the things about research, the basic um, things to consider, the basic pointers on how to develop or create or write a research paper, a thesis, to how to build your manuscript, right? And then the last topic that we have is the null hypothesis. That the null hypothesis is a statement that a relationship expected in the research hypothesis does not exist. That the world is simpler. For example, that the world is simpler than predicted by theory. Like there is no difference in how much young and older people to protest. So in the previous video, we talk about and we have this example. Like the hypothesis would be you are trying to prove that uh, younger people are tend to attend protest or rally or something like that uh, compared to older people. But the null hypothesis is that there is no difference in the active participation of young people or the older people when it comes to age. So maybe it depends on the political views or whatever topics that the protest is anchored on. Okay, so that is the null hypothesis. And then as of this as of today, we are going to talk about a continuation, some of the topics that are needed to be known before writing a thesis, a research paper. So one of the list is first on the list is the Occam's principle or law of razor or law of parsimony. So if we have two explanations of the world which are equally good in predicting outcomes, we should prefer the simpler explanation. Yes, maybe. Or no, I don't know. But the correct way is, why would we choose a complex way of solving things when there is a much better and simpler explanation to that? Okay, so question: why should we prefer simple explanations? According to Popper, we prefer simpler theories to more complex ones because their empirical content is greater and because they are better testable. So better testable, mas madali siyang i-test. So testable siya, better testable, mas sure yung magiging outcome ng research mm, using the theory. And then, according to Richard Swinburne, other science is irrational in the way it judges theories and predictions probable, or the principle of simplicity is a fundamental synthetic a priori truth. Okay. Then, and according to Ludwig Wittgenstein, Occam's principle is, of course, not an arbitrary rule nor one just justified by its practical success. It simply says that unnecessary elements in a symbolism mean nothing. Signs that serve one purpose are logically equivalent, then signs that serve no purpose are logically meaningless. Okay. The procedure of induction consists in accepting as true the simplest law that can be reconciled with experiences. Like for example, the books given as an example, it says the hypothesis that the world is predetermined is unbelievably complex and of no use for predicting the future. So it will be a very low priority in our set of theories because why would what is the purpose of having you predicting the future if the world is predetermined, everything is laid up, everything is already planned, it is going to happen, you don't have any sort of um, interventions into it, that it will create another scenario, it will sway from the predetermined path. So what's the point of predicting the future, and it is unbelievably complex. And how can scientists, so how can we prove the hypothesis that the world is predetermined? Like if this is, we'll say, okay, young man, you are going to marry a rich lady or woman in the next 10 years. Now, how can we say that this young man would really marry a young and rich woman after 10 years? If it is predetermined, how can we explain the that it is predetermined? How can we prove that it is predetermined? How can we do that? No? So yeah, so that is a unbelievably complex idea or of a hypothesis. So we prefer a much simpler theory though, because it is easier to prove. If statistical models are used, we expect the null hypothesis to be rejected, and hence the alternative research hypothesis to be attainable or believable. So the null and the alternative are thus usually complementary. The null hypothesis is usually the simpler statement, the null hypothesis, such as there is no effect caused by something, while the research hypothesis would be that there is an effect. Let's say the null hypothesis would be there is no uh, relation between the amount of garbage in Pagadian City to the behavior of Pagadianons. So that is the null hypothesis. You believe that it's really not the behavior of Pagadianons that it comes to the situation that the city of Pagadian has too many garbages if you look around. That's the null hypothesis. Okay? There is no you say that there is no relation between the number of garbages and the behavior of Pagadianons. That's the null hypothesis. And if you say your hypothesis, not the null hypothesis, your actual hypothesis is that you want to prove that because of the behavior, these types of behavior of Pagadianons, uh, now Pagadian has a lot of garbages scattered around the streets or whatever. That's the hypothesis. You want to prove that because of this behavior of Pagadianons, that is why there are a lot of garbages around Pagadian City. So that is the hypothesis. In contrast to the null hypothesis. Okay? Though we can only disprove rather than prove hypotheses. Hence, we look for evidence to disprove the null hypothesis, and if we cannot find sufficient evidence, we accept the null hypothesis. Strictly speaking, statistics cannot usually even disprove a hypothesis. It can at most show that the outcome we observe was or very unlikely if we assume that the null hypothesis is true. This is because statistics uses probability, chance statements rather than absolute statements. So probability, how many percent, or according to statistics, how closer are we to the conclusion that there is really an evidence, a sufficient evidence that prove this hypothesis is true. If we cannot prove this hypothesis, hindi natin mapapatunayan na tama yung hypothesis natin, yung haka. Bali, para siyang matatawag nating haka-haka. Kung hindi natin siya ma-prove na tunay yung ginawa nating hypothesis, then we will accept the null hypothesis instead. Okay? We'll come back to the question of what constitutes sufficient evidence. For example, um, if I toss a coin 20 times and every time I get ahead, would you believe this is a fair coin? Has one head and one tail. One head, one tail. The chance is about 1 in a million of observing this outcome with a fair coin, but a certainty if my coin has two heads. Right? So 20 times. Toss the coin 20 times. And every time I get ahead. So for that 20 times, you always get a head. So 20 times toss, 20 times the head comes up. Would you believe that it is a fair coin? Because it has one head and one tail, right? But what are the chances? So the chance is about 1 in a million of observing this outcome with a fair coin. But a certainty, if my coin has two heads, you will only get 20 head and 20 toss if your coin has both sides are heads. So the other side is head, and the other side is head, no tail. We will really get 20 heads and 20 times you toss the coin. If that's the case, but since the coin has one head and one tail, so the chance is about a million. So you're going to prove that. But it could happen. It could happen. It could happen that in 20 times you toss the coin, it will produce 20 heads without miss. But how can you prove that it is once in a million chance that it will happen? So right. So that is the hypothesis. So how do we define simplicity? Often it is defined in terms of the number of parameters in our statistical model, or the sample size minus the number of parameters in our statistical model, which we call the degrees of freedom. According to this book, we will revisit this, where simplicity means the number of parameters is small or the degrees of freedom are large. So if we talk about proof, proof means that you know the truth for certain. Alam mo yung totoo, alam mo yung talagang nangyari or magiging basihan. What is verified? Verified means that you test did not disprove the truth. Okay, so you know the truth. Now, since you know the truth, you have the proof. How can you prove that truth? You have to verify that truth. You have to test that truth to not disprove the truth. Okay? You have the truth, you believe that is the truth. That means you should have a proof. So how can you have a proof? You have to verify that proof. You have to test. So if I compare your face to your picture in your identity card or passport and they match, I have verified your identity. But it is not proof because you might have an identical twin or have obtained a fake document. Anyone get it? So proof and truth. I have verified. Okay? The example is simply you give me your ID, I look at your ID, I compare the face in your ID to your actual face. I did verify that the face in this ID is really you. It really looks like you. But the question is it really you? You could have a twin. And this one in the picture in the ID is your twin, not you. Then the other question here is this ID card a true ID card? Is this not a fake document? Did you fake your document? So I need to prove these two questions first. I have to verify or additional proof that this is really a true document, not a fake document, and that the picture in this document is really you and not your twin. Because you, as you having an identical twin is a possibility. Now in research, we always look at the possibility since we talk about statistical probability. Okay, so that is how you build your proof and to verify your truth. In thesis writing, you are going to implement this in your if I'm not wrong, in your um, chapter 5 before you can have your conclusion in chapter 6. Okay? So if you test many hypotheses resulting from a theory and none of them are shown to be false, you may think the theory is true because of numerous verifications, but you still have not proved it. It may be that the weakness is the theory have not been identified yet. The theory of relativity and Newton's laws. So, say for example, you test your theory or you test your hypothesis, yung pananaw mo na ito yung totoong gusto mo i-prove, yung hypothesis, na i-test mo siya gamit yung iba't ibang theory, and every theories you use to test that hypothesis results to true. It does not mean na yun na yung totoo, na tama yung hypothesis mo. Maybe you need to uh, explore more or test your hypothesis more on a much complex or other theory. It says it may be that the weaknesses in the theory have not been identified yet. Uh, Another thing is maybe that that theory that you use in proving your hypothesis is not a solid theory. There is a flaw. Okay? Meron pa siyang mali, meron siyang kulang, or meron siyang sobra. Kailangan pa siyang i-perfect yung theory na ginamit mo. Oh, pwede 'yon. So what is constant? A constant is something that is assumed, does not vary over the study, and hence cannot explain anything that does vary over the study. Constant, di nagbabago. A constant is something that it is assumed does not vary over the study and hence cannot explain anything that does vary over the study. That is a constant variable. Okay? So in mathematics, we do have some constant variables. Hindi siya pwedeng baguhin. Talagang andyan lang siya. Let's say for example like the pi. The pi value is 3.1416, and we could not change that. That is a constant value. So it is something like that. And then the next one is, what is a random variable? You see, a random variable is something that varies over time or over subjects. So in other words, varies within the study. So it changes, a random variable. Also used to mean the operational definition of a concept. How do we measure something? Creating a good operational definition is a skill, and it is important to look at previous work. Hence the importance of a good literature review. So we will discuss operational definitions later, including evaluation and operational definitions. So when you say random variable, it changes over time. As you go on to the process of research, it changes. Maybe in the first time that this thing is being researched, this is the value, this is the value of this variable, and then over time another researcher used that theory or used that method, and then look into the same almost the same concept of research, and then this variable is has changed, and then as to your current research, it changes over time. That is a random variable. It is not like the constant that it will never change, it will never be changed. Then what is an explanatory variable? Explanatory variables are random variables that are the object of research. Either they are included in the research hypothesis. Included in the research hypothesis, those explanatory variables. So random variables. And then um, what is an independent variable? An independent variable is an explanatory variable also that is presumed cause of variation in another explanatory variable. So when I say independent variable is yung mga variable na uh, hindi na aapektuhan sa course ng research mo. Independent variables sila, hindi mo pwedeng hindi siya pwedeng mabago dahil dun sa ibang variable. While the dependent variable is an explanatory variable also, that is the outcome variable presumed to be affected by the independent variable. If there is an independent variable, so the dependent variable will it is the result based on the independent variable. Ano yung ginawa mo doon sa explanatory variable mo, the independent variable, magiging outcome nun could affect the dependent variable. Okay? So for example, your dependent variable is we have here if there are independent variables, the null and the research hypothesis must be describable in terms of the dependent and independent variables. In most scenarios, the research hypothesis is that the independent variables affect the dependent variables, and the null hypothesis is that the independent variables do not affect the dependent variables. So if there are no independent variables, the hypothesis must be describable in terms of the dependent variables only. Like for example, the fair coin hypothesis is described only in terms of chance of heads and tails. So the chance of heads and tails. So the outcome there is how many heads and how many tails will be as a result in tossing the coins in 20 times. So the dependent variable is the number of heads and the number of tails as a result out of 20 toss of that fair coin. That's the dependent variable. It depends on the luck and on the how many times the toss is performed. Now the independent variable is uh, the the number of toss. Okay, so that's the independent variable. So you could say the independent variable is um, toss. Okay, tossing the coin. Now the constant is we say 20 times. 20 times. Now the dependent variable is the number of heads and the number of tails within that 20 times of tossing the fair coin. So what are the extraneous variables? So another variables, extraneous variables are random variables that are not objects of research. It's not an object of research. We can say it is the external variable. Confounding, we have one extraneous variable that are related to independent variables. So related to independent variable. Controlled extraneous variables that are either manipulated or included in a statistical model so as to exclude the effect on the relationship between independent and dependent variables for confounding variables. So to reduce the variability of the dependent variable. While the third one is uncontrolled. So if you see extraneous variables that are not been controlled, and then the next is some relevant, which is an extraneous variables, believed not to play any role in the research. So there is nothing. There these assumed irrelevant is an extraneous variables that is believed not to play in the role in the research. It is what do you call this, a an excess variable. Okay, uncontrolled variable is the one that you don't have a control with. It does not depend on you or on the research. It depends on the course of some other interventions. And then the control is the variable, extraneous variable that is being affected or manipulated through statistical model by the and it has a relationship between independent and dependent variable, while confounding extraneous variables that are related to independent variables. So clearly the research is at rest if there are important uncontrolled variables, or if the variables assumed are relevant are confounding variables. And it is important that is stating our research problem that we give careful thought and check the research literature as always to allocate variables correctly. In practice, there are limits to how many variables we can control for. So we need to ensure that that we control for those with the largest potential effect on our explanatory variables. Controlling is an attempt to exclude the effects of variables that are not of interest. So mechanism and control. So uh, about mechanism of control. So one category fix all subjects to have the same value of a controlling variable. The disadvantage is that the conclusion cannot be generalized to other values of the controlling variable if you have only one category. So much like you need to have multiple categories in your research or variable. Block control divide up subjects by value of controlling variable and study separately. Like study about males, study about the females separately. Good for simple situations with only a few blocks, but often impractical for multiple controlling variables as the block size gets too small, too few subjects per block. So pag meron ka namang dinivide mo masyado yung subjects mo, magiging napakakunti nung i-observe mo na subject. So parang magiging hindi na din reliable yung magiging outcome mo. Okay? So block control is good if the number of participants subjects is large, not that too small. So you have to minimize also how many blocks to control. Like say for example, the age of a person. If your subject is a person, you have to divide the age from, we don't say 5 to 10, 11 to 15, 16 to 20, but we could have uh, 1 to 5 to 15, and then 16 to 30, something like that. Okay, then randomization, assign subjects to groups using chance. In a study of medical treatments, assume that the assignment choice is possible. Randomization is an invaluable approach because it means that the groups should be similar on all uncontrolled variables and on all variable assumed relevant. So this is how we categorize the our subject and research. Yung magiging pagkukunan mo ng sample. Pag one category lang, basta lahat, sabihin natin na lahat ng nagtatrabaho sa Pagadian City. So yun, one category yun. Lahat ng nagtatrabaho sa Pagadian City. Pag sinabi natin block control, lahat ng nagtatrabaho sa Pagadian City per uh, let's say per sector. Education sector, meron dun sa business, yung ganon. Block control na yun. Pag randomization naman, so from a large group of subject, we randomize. So parang nag-ano tayo dito, naglaro tayo ng loto. So from 1,000 subjects, let's just create a jumble, then randomization. Oh, ito si number 1 dito ka sa group na to, si number 2 dito sa group na to. So paired control. Pag sinabing paired control, per subject to be similar on several variables and randomly assigned to groups from pair. Okay, so paired control. Per subjects to be similar on several variables. So, ikaw may asthma, siya may asthma, so dito kayo. Although yung isa is lalaki, yung isa is babae, pero pareho kayong may asthma, so dito kayo. Yung dalawa naman, pareho kayong walang asthma, pareho kayong yung ganon. So, pair control. Statistical control. Try to control using a statistical model. This assumes that a statistical model is good enough to completely remove the effect. So, we'll use the statistics assuming that the statistical model is good enough. But if you are not sure that the statistical model is good to be used in your research, then statistical control is not for you to use. Measurement error and practice, none of these controlling mechanisms are perfect. So because there may be errors in the measurement of the controlling variables, that's for sure. Example, early passive smoking studies look at non-smoking women with smoking husbands, but did not account for the problem that some people lie about smoking, but not usually lie about smoking, and that it is more likely for people to lie if you are married or a smoker, which together lead to bias and estimate of passive smoking effects. So this problem can be solved if we can eliminate or model the measurement errors. In our example, we can check urine or hair sample to check how much people smoke. So that's the measurement of error. We will use that we are going to study that uh, in our statistics. Uh, the Cronbach Alpha. Okay, we talk about Cronbach Alpha. So how much or how much greater is the margin of error when you are using a statistical model to gather information. So alin doon yung paano mo siya i-detect yung mga tamang respond at yung mga respond na hindi totoo. So paano mo yun i-capture using your material, your questionnaire, kumbaga. Pag say for example nag-survey ka. So that is measurement error. Note that controlling methods that rely on allocation are only feasible if the researcher can allocate subjects to groups, which may be infeasible or unethical. Example, smoking for humans. The control variables may also interact. Effect of income within males may differ from within females. So, control variables yan kasi ginawa natin siyang two groups, two categories, which is the male and female. And then yung subject natin is yung income, yun yung ating variable. Income is a variable, then we the effect. So tingnan natin kung mas madali ba or mas malaki ba yung kikitain ng mga male or yung mga female. So propensity scoring. When the allocation is non-random, we can look at possible bias by examining the conditional probability that a subject will be treated given the observed explanatory variables to the propensity score. If we stratify by propensity score, we obtain estimated treatment effects that are not biased by the measured explanatory variables. So for this case, we can use the paper of Rosenbaum and Robbins in the 1983. It is the biometrica paper, the central role of the propensity score in observational studies for causal effects. Then that would be our reference if you want to have a more detailed explanation on the propensity. For example, the classic 1950 paper by Dahl and Bradford held in British Medical Journal, Smoking and Carcinoma of the Lung, examined frequency, T-balls of lung cancer or control other hospital patients matched by gender, age, and hospital. By gender and smoking or not, the research hypothesis is that smoking is associated with lung cancer, while the null hypothesis is that there is no association. Lung cancer or not is the dependent variable. And then smoking or not is the independent variable because the smoking or not is the one that we are going to test. Okay, if that smoking or not smoking has an effect to a lung cancer, so that lung cancer or no lung cancer is the dependent variable. It depends on the independent variable, the one that we are testing, the smoking or not smoking. While gender, age, and hospital are the control variable because we group it by gender because it could be that more males are prone to lung cancer because more male are smoking with regards to uh, uh, against women, no, or unlike women. And then as to the age, so how much or what is the range of age that a male or a female used to smoke. And then also the hospital are control variables, because uh, we look at into which hospital is the has many patients that has a lung cancer that is connected to the smoking or not smoking. Okay, so whether a random variable is an independent variable or control, or cannot be both, may not be obvious without checking the research hypothesis. So the independent variable is included, control is not. So Mendelian randomization. So when we say Mendelian randomization, it was discovered by Mendel that when he crossed purebred white flower and purple flower pea plants, the result was not a blend, so rather than being a mix of two. So the offspring, known as the figure F1 generation, was purple flowered, but when Mendel self-fertilized the F1 generation pea plants, he obtained a purple flower to white flower ratio in F2 generation of 3 to 1. So just suggesting that separate genes for separate traits are passed independently of one another from parents to offspring. So instead na meron kang pink at saka meron kang uh, say meron kang purple at saka white. So it depends. It could be purple, it could be white. No? Naghalo-halo na yung gene. So we can use the random assignment of an individual's genotype from parental genotypes uh, and that occurs before conception to make causal inferences, assuming that the genotype is associated with the exposure of interest and dependence of the genotype from the confounding factors and from the outcome given the exposure and confounding factors. So the strength of this is that it does not rely on allocation, so it's a randomization. So the Mendel randomization of crossbreeding. Okay. So those are possible methods we can use on how to test our subject, on how to test our population. That is the source of our information to prove something in a research. So these are the mechanism. That's how you control your study, your research study. Paano mo i-group yung mga pagkukunan mo ng data, ng information. It could be by one category, block controller, randomization, per control, statistical control, then never forget the measurement error, and then propensity scoring, and then the Mendelian randomization. So yun yung pwede nating gawin or gamitin kapag tinetest natin yung ating hypothesis using a method. So we are going to use this mechanism control. Okay. So this material is uploaded in our Google Classroom. So if you want to study or to read this text or this book, visit the classroom and download a PDF copy from the classroom. And so those are the topics that I want to share with you today. I hope you have learned something, and thank you so much.